Hello students, welcome to this lecture 1 Polynomials. So in this lecture we will discuss NCERT Exemplar problem 1 Polynomial. Okay, so let us start. So in this section we will discuss very short answer type questions. Okay, so here answer the following and justify. So in first one here we have, can x square minus 1 be the quotient 1 division of x to the power 6 plus 2x cube plus x minus 1 by a polynomial in x of degree 5. Okay, so let us check. So the answer is no, because whenever we divide a polynomial x to the power 6 plus 2, whenever we divide the polynomial x to the power 6 plus 2x cube plus x minus 1 by a polynomial in x of degree 5, then we get quotient always as a quotient as in linear form. Okay, that is polynomial in x of degree 1. So let divisors a polynomials in x of degree 5. Okay, so here we let this is equal to ax to the power 5 plus bx to the power 4 plus cx to the power 3 plus dx square plus ex plus f. Okay, and here quotient is x square minus 1. Okay, and dividend, this is equal to x to the power 6 plus 2x cube plus x minus 1. So by division algorithm for polynomials, dividend, this is equal to divisors into quotient plus remainder. Okay, so here divisors is equal to this and quotient is x square minus 1 and remainder is don't know. Okay, so this is equal to x to the power 5 plus bx to the power 4 plus cx to the power 3 plus dx square plus ex plus f into x square minus 1 plus remainder, and this is equal to a polynomial of degree 7 plus remainder. So in division algorithm, degree of divisor is always greater than degree of remainder. Okay, so the polynomial of degree 7, but dividend a polynomial of degree 6. So algorithm division is not satisfied here. So hence x square minus 1 is not a required quotient. Okay, so x square minus 1, this is not a required quotient. So this is not a required quotient of this polynomial via polynomial in x of degree 5. Okay, and then in next one here, what will be the quotient and the remainder be a division of ax square plus bx plus c by px cube plus qx square plus rx plus s, where p does not equal to 0. Okay, so let us see the solution. So in second one here, given that divisor, this is equal to px cube plus qx square plus rx plus s, where p does not equal to 0, and dividend, this is equal to ax square plus bx plus c, and we see that degree of divisor, this is greater than degree of dividend. So by the division algorithm, quotient is equal to 0 and remainder is equal to ax square plus bx plus c, and if degree of dividend, this is less than degree of divisor, then quotient will be 0 and remainder as well as dividend. Okay, so if that quotient and the remainder of the division will be the degree of the quotient will be 0 and remainder as well as dividend. Okay, and then let us see next one. So in next one here, if one division of a polynomial p of x via polynomial g of x, the quotient is 0, what is the relation between the degree of p of x and g of x? Okay, so now let us find the degree of p of x and g of x. So if division of a polynomial p of x via polynomial g of x, the quotient is 0, and then relation between the degrees of p of x and g of x is degree of p of x less than degree of g of x. Okay, So degree of p of x is less than degree of p of x. This is the relation between the degrees of p of x and g of x. Now let us move to next one. So in next one here we have asked, can the quadratic polynomial x square plus kx plus k have equal zeros for some odd integer k greater than 1? Okay, so let us see the answer. So here the answer is no. Let p of x, this is equal to x square plus kx plus k, and if p of x has equal zeros, then its discriminant should be 0. Okay, therefore d, this is equal to b square minus 4ac, and this is equal to 0. When comparing p of x with ax square plus bx plus c, here we get a is equal to 1, b is equal to k, and c is equal to k. Therefore k square minus 4 times 1 into k, this is equal to 0. So it implies k times k minus 4, this is equal to 0, and it implies k is equal to 0 and 4. Okay, so the quadratic polynomial p of x have equal zeros only at k equal to 0 and 4. And now let us move to next problem. So in next problem here we have are the following of a quadratic polynomial ax square plus bx plus c are both positive, then a, b and c will have the same sign. Okay, so let us check whether this is correct or not. Okay, so this is actually false. If the zeros of a quadratic polynomial ax square plus bx plus c are both positive, then sum of zeros alpha plus beta, this is equal to minus b upon a. Okay, that we know sum of zeros, this is equal to minus coefficient of x divided by coefficient of x square. Okay, and we know product of zeros, that is equal to alpha times beta, this is equal to constant term c divided by coefficient of x square, that is a. Okay, where alpha and beta are the zeros of quadratic polynomial. Okay, therefore c is less than 0 and a is less than 0 also. Okay, and b is greater than 0. Where c is greater than 0, a is greater than 0, and b is less than 0. Okay, so this statement, if the zeros of the quadratic polynomial ax square plus bx plus c are both positive, then a, b and c will have the same sign. This statement is a false statement. Okay, so now let us see next one. So in next one here it said to us, if the graph of a polynomial intersects the x-axis at only one point, then it cannot be a quadratic polynomial. Okay, so let us see the answer. This statement actually true statement, because if the graph of a polynomial intersects the x-axis at only one point, then it cannot be a quadratic polynomial, because a quadratic polynomial may touch the x-axis at exactly one point, were increasing intersect x-axis at exactly 2 points, but do not touch the x-axis. Okay, so that is why this statement is a true statement. And now let us see next one statement. So next in 3 we have, if the graph of a polynomial intersects the x-axis at exactly 2 points, then it need not be a quadratic polynomial. Okay, so let us see third one. So in third one, if the graph of a polynomial intersects the x-axis at only one point, then it cannot be a quadratic polynomial, that we have seen. And if the graph of a polynomial intersects the x-axis at exactly 2 points, then it may or may not be a quadratic polynomial, as a polynomial of degree more than z is possible, which intersects the x-axis at exactly 2 points when it has 2 real roots and other imaginary roots. Okay, so this statement, the given statement in 3, is a true statement. Okay, and let us see fourth statement. Okay, so in fourth statement here we have, if two of the zeros of a cubic polynomial are 0, then it does not have linear and constant terms. Okay, so let us see the answer of fourth one. So in fourth one here we can let alpha, beta and gamma be the zeros of the cubic polynomial, and given that two of the zeros have value 0. Okay, so here we let beta is equal to gamma is equal to 0. Okay, and p of x, this is equal to x minus alpha into x minus beta into x minus gamma. Okay, and this is equal to x minus alpha times x minus 0 into x minus 0. Okay, and this is equal to x cubed minus ax square, which does not have linear and constant term. Okay, so the statement in fourth one here, this statement, if two of the zeros of a cubic polynomial are 0, then it does not have linear and constant term. So this statement is a false statement. And now let us see fifth one. So in fifth one here we have, if all the zeros of a cubic polynomial are negative, then all the coefficients and the constant term of the polynomial have the same sign. Okay, so let us see the answer of fifth one. So here this statement is a true statement. If we take f of x, this is equal to ax cube plus bx square plus cx plus d. Then for all negative roots, a, b, c and d must have same sign. Okay, so the given statement is a true statement. Okay, and now let us see sixth one. So in sixth here we have, if all the three zeros of a cubic polynomial x cube plus ax square minus bx plus c are positive, then at least one of a, b and c is non-negative. Okay, so let us see the answer. Okay, so the answer is actually false. If we let alpha, beta and gamma be the three zeros of the cubic polynomial x cube plus ax square minus bx plus c, okay, then product of zeros, that is equal to minus constant term divided by coefficient of x cube. Okay, and it implies alpha, beta, gamma, this is equal to minus c upon 1, and it implies alpha, beta, gamma, this is equal to minus c. Okay, so given that all three zeros are positive, so the product of all three zeros is also positive, that is alpha, beta, gamma, this is greater than 0. Okay, and it implies minus c is greater than 0, and it implies c is less than 0. Okay, so now sum of the zeros of a cubic polynomial, this is equal to alpha plus beta plus gamma, and this is equal to minus coefficient of x square divided by coefficient of x cube. Okay, and it implies alpha plus beta plus gamma, this is equal to minus a upon 1, and this is equal to minus a. But alpha, beta, gamma are all positive, thus its sum is also positive. Okay, so alpha plus beta plus gamma, this is greater than 0. Okay, and it implies minus a is greater than 0, and it implies a is less than 0. Okay, and sum of the product of two zeros at a time, this is equal to coefficient of x divided by coefficient of x cube. Okay, so alpha beta plus beta gamma plus gamma alpha, this is equal to minus b. Okay, and since alpha beta plus beta gamma plus alpha gamma is greater than 0, since alpha beta gamma three roots are all positive. Okay, so it implies minus b is greater than 0, and it implies b is less than 0. So the cubic polynomial x cube plus ax square minus bx plus c has all three zeros which are positive only when all constants a, b and c are negative. Okay, so the given statement in 6, this is actually a false statement. Okay, and now let us see seventh statement. So in seventh statement here we have the only value of k for which the quadratic polynomial kx square plus x plus k has equal zeros, okay, is 1 by 2. Okay, so now let us see the answer. So here In seventh one, first of all, we let f of x, this is equal to kx square plus x plus k. Okay, and for equal roots, its discriminant should be 0. Okay, that is d is equal to b square minus 4ac, that is equal to 0. Okay, and here the a is equal to k, b is equal to 1, and c is equal to k. Okay, so 1 minus 4k into k, this is equal to 0, and it implies minus 4k square is equal to minus 1, that implies k square is equal to 1 by 4, and it implies k is equal to plus minus 1 by 2. Okay, so for two values of k, even the quadratic polynomial has equal zeros. Okay, so the given statement in seventh one, this is actually a false statement. Okay, so now let us move to next section. So in next section, here we will discuss short answer type questions. Okay, so in first question, here we have to find the zeros of the following polynomials by factorization method and verify the relations between the zeros and the coefficients of the polynomial. Okay, so let us find the zeros of this quadratic polynomial. Okay, so here we'll see first of all thinking process. So here we firstly use the factorization method, that is splitting the middle term of a quadratic polynomial and find its zeros. Okay, after that use the formula of sum of zeros and product of zeros for verification. Okay, so let f of x, this is equal to 4x square minus 3x minus 1. Okay, and now by splitting the middle term, then here the middle term is minus 3x, and we can split middle term minus 3x as minus 4x plus x. Okay, so then this is equal to 4x square minus 4x plus x minus 1, and this is equal to 4x times x minus 1 plus 1 into x minus 1, that is equal to x minus 1 times 4x plus 1. Okay, so the value of 4x square minus 3x minus 1 is 0 when x is equal to 1 or 4x plus 1 is equal to 0. Okay, when x is equal to 1 or x is equal to minus 1 by 4. So the zeros of 4x square minus 3x minus 1 are 1 and minus 1 by 4. And now therefore sum of zeros, that is equal to 1 minus 1 by 4, and this is equal to 3 by 4. Okay, and this is equal to minus of minus 3 by 4, and this is equal to minus coefficient of x divided by coefficient of x square. And now product of zeros, that is equal to 1 into minus 1 by 4, and this is equal to minus 1 by 4, and this is equal to constant term divided by coefficient of x square. Hence verified the relation between the zeros and the coefficients of polynomials. And now let us see next quadratic polynomial, 3x square plus 4x minus 4. Okay, so now let us see the answer. So here first of all let f of x is equal to 3x square plus 4x minus 4, and now by splitting the middle term factor, here you can split the middle term 4x as 6x minus 2x, then this is equal to 3x square plus 6x minus 2x minus 4, and this is equal to 3x times x plus 2 minus 2 times x plus 2, and this is equal to x plus 2 times 3x minus 2. Okay, so the value of 3x square plus 4x minus 4 is 0 when x plus 2 is equal to 0 or 3x minus 2 is equal to 0, that is when x is equal to minus 2 or x is equal to 2 by 3. So the zeros of 3x square plus 4x minus 4 are minus 2 and 2 by 3. Okay, now let us verify sum of zeros, relation between coefficients of quadratic polynomial and its zeros. Okay, so here the sum of zeros, this is equal to minus 2 plus 2 by 3, that is equal to minus 4 by 3, and you can write this is equal to minus coefficient of x by coefficient of x square. And now product of zeros, this is equal to minus 2 times 2 by 3, that is equal to minus 4 by 3, and this is equal to actually constant term that is minus 4, and the coefficient of x square, and here the coefficient of x square is 3. Okay, so hence verify the relation between the zeros and the coefficients of the polynomial. Now let us see third one. So in third one we have given this quadratic polynomial 5t square plus 12t plus 7. Okay, so now let us see the answer. So here first of all let f of x, this is equal to 5t square plus 12t plus 7. Okay, and now if we splitting the middle term, then we get 5t square plus 7t plus 5t plus 7. Okay, and it implies t into 5t plus 7 plus 1 into 5t plus 7. Okay, and this is equal to 5t plus 7 into t plus 1. And now so the value of 5t square plus 12t plus 7 is 0 when 5t plus 7 is equal to 0 or t plus 1 is equal to 0. That is when t is equal to minus 7 by 5 or t is equal to minus 1. Okay, so the zeros of 5t square plus 12t plus 7 are minus 7 by 5 and minus 1. Okay, so therefore the sum of zeros, this is equal to minus 7 by 5 minus 1, and this is equal to minus 12 by 5, and this can be written as minus coefficient of t divided by coefficient of t square, and product of zeros, this is equal to minus 7 by 5 into minus 1, that is equal to 7 by 5. Okay, and you can write this is equal to constant term divided by coefficient of t square. Okay, hence verify the relation between the zeros and the coefficients of the polynomial. Now let us see the fourth one. So in fourth one, here we have the quadratic cubic polynomial t cube minus 2t square minus 15t. Okay, so let us see the answer. Here first let t cube f of t is equal to t cube minus 2t square minus 14t, and here we can common out t. Okay, then this is equal to t times t square minus 2t minus 15. Okay, and now we can splitting the middle term of this quadratic polynomial. Okay, and this is equal to t times t square minus 5t plus 3t minus 15. Okay, and this is equal to t times t into t minus 5 plus 3 times t minus 5, and this is equal to t times t minus 5 times t plus 3. Okay, so the value of t cube minus 2t square minus 15t is 0 when t is equal to 0 or t minus 5 is equal to 0 or t plus 3 is equal to 0. Okay, that is when t is equal to 0 or t is equal to 5 or t is equal to minus 3. Okay, so the zeros of t cube minus 2t square minus 15t are 0, 5 and minus 3. Okay, so therefore sum of 0 is equal to minus 3 plus 0 plus 5, that is equal to 2, and you can write 2 as minus of minus 2 by 1, and you can write this is equal to minus coefficient of t square divided by coefficient of t cube. And now sum of product of two zeros at at a time a. Okay, that is equal to minus 3 times 0 plus 0 into 5 into plus 5 into minus 3, and this is equal to minus 15, and you can write this is equal to coefficient of t by coefficient of t cube. And now product of zeros, this is equal to minus 3 into 0 into 5, that is equal to 0, and this is actually equal to constant term minus of constant term divided by coefficient of t cube. Okay, hence verified the relations between the zeros and the coefficients of the polynomial. And now let us see fifth one. So in fifth one, here we have this quadratic polynomial 2x square plus 7 by 2x plus 3 by 4. Okay, so now let us see the answer. So here first of all let f of x, this is equal to 2x square plus 7 by 2x plus 3 by 4, and you can write it as 8x square plus 14x plus 3. Okay, and it is equal to 8x square plus 12x plus 2x plus 3, and this is equal to 4x times 2x plus 3 plus 1 times 2x plus 3, and this is equal to 2x plus 3 plus, into 4x plus 1. And now the value of 8x square plus 14x plus 3 is 0 when 2x plus 3 is equal to 0 or 4x plus 1 is equal to 0. That is when x is equal to minus 3 by 2 or x is equal to minus 1 by 4. Okay, so the zeros of 8x square plus 14x plus 3 are minus 3 by 2 and minus 1 by 4. Okay, so now let us check the relations between the zeros of a quadratic polynomial and its coefficients. Okay, so sum of zeros, this is equal to minus 3 by 2 minus 1 by 4, that is equal to minus 7 by 4, and you can write minus 7 by 4 as minus 2 by 2 times 2, and that is equal to minus coefficient of x divided by coefficient of x square. Okay, and now product of zeros, that is equal to minus 3 by 2 into minus 1 by 4, and this is equal to actually 3 by 8, and you can write 3 by 8 as 3 by 2 times 4. Okay, that is equal to constant term divided by coefficient of x square. Hence, verified the relation between the zeros and the coefficients of the polynomial. Okay, now let us move to sixth question. So in sixth question, here we have the quadratic polynomial 4x square plus 5 times root 2x minus 3. Okay, so let us see the answer. So here let f of x is equal to 4x square plus 5 times root 2x minus 3. Okay, so now by using splitting the middle term, here we can write this expression as 4x square plus 6 times root 2x minus root 2x minus 3. Okay, and this is actually equal to root 2x plus 3 times 2 times root 2x minus 1. Okay, now so the value of 4x square plus 5 times root 2x minus 3 is 0 when root 2x plus 3 is 0, or 2 times root 2x plus 2 times root 2x minus 1 is equal to 0. Okay, that is when x is equal to minus 3 by root 2 or x is equal to 1 by 2 times root 2. So the zeros of 4x square plus 5 times root 2x minus 3 are minus 3 by root 2 and 1 by 2 times root 2. Okay, so now sum of zeros, that is equal to minus 3 by root 2 plus 1 by 2 times root 2, that is equal to minus 5 times root 2 by 4. Okay, and this is actually equal to minus coefficient of x by coefficient of x square. And product of zeros, this is equal to minus 3 by root 2 times 1 by 2 times root 2, that is equal to minus 3 by 4, and this is equal to actually constant term divided by coefficient of x square. Okay, hence verify the relations between the zeros and the coefficient of the polynomial. And now let us see question number 7. So in question number 7, here we have the quadratic polynomial 2s square minus 1 plus 2 times root 2s plus root 2. Okay, so now let us see the answer. So first let f of s, this is equal to 2s square minus 1 plus 2 times root 2s plus root 2. Okay, and this is equal to 2s square minus s minus 2 times root 2s plus root 2, and this is equal to s times 2s minus 1 minus root 2 times 2s minus 1, and this is equal to 2s minus 1 times s minus root 2. So the value of 2s square minus 1 plus 2 times root 2s plus root 2 is 0 when 2s minus 1 is equal to 0 or s minus root 2 is 0. Okay, that is when s is equal to 1 by 2 or s is equal to root 2. So the zeros of 2s square minus 1 plus 2 times root 2s plus root 2 are 1 by 2 and root 2. Okay, so therefore the sum of 0 is equal to 1 by 2 plus root 2, that is equal to 1 plus 2 times root 2 by 2, that is equal to minus of minus 1 plus 2 times root 2 by 2, and this is actually equal to minus coefficient of s by coefficient of s square. Okay, and product of 0, this is equal to 1 by 2 into root 2, that is 1 by root 2, and this is actually equal to constant term divided by coefficient of s square. So hence verify the relation between the zeros and the coefficients of the polynomial. So this is all about this lecture. I stop here this lecture. Thank you very much to all of you.